What we're going to do is define quite a few different vocabulary words and then take some business aspects in order to work through the situations. So the first word we want to look at is total cost. The total cost is the cost of total cost of production and elements. And so what it's going to take into account is when you're looking at the total cost, it's going to take in the fixed costs, which we're going to define in just a minute, plus the variable cost times Q. Now, when we're referencing Q through this, Q is going to be equal to our quantity. Okay, so as we look at all these different words, these are going to be vocabulary that we're going to use for the remainder of the course. And so I want to make sure we outline them here, and then we're going to keep using them as we go on, so you'll have a good reference. So in total cost, it's taking fixed cost and variable cost and adding them together. So let's define those as well. A fixed cost is going to be your startup cost. When you're thinking about startup costs, you want to think about maybe the equipment that you have to purchase to make a product, the building maybe that you had to buy or rent every month. It's things that are not going to change. Your variable cost is going to be based off the number of items produced. And so the things that are going to go into your variable cost are going to be your materials and your labor. So say we're making a cup. If we make more cups, our building cost is not going to go up. The equipment to make the cup is not going to go up, but the plastic to make the cup we have to buy more of. If we're selling a whole lot of cups, we might have to employ more labor or pay more labor for people to make the cups using the said machines, etc. So your variable cost is the one that's based off your quantity. And so that's why up here when you were looking at total cost, having a multiplier on it, it's because, again, if you're making cups, you're going to have to buy more materials for that cup, employ more people for that cup. Now, total cost is all about how much money is it going to take to do this? Revenue is the amount of money a company brings in from sales. And so we're just going to stick with our cup example. When we're thinking about maybe an equation for revenue, we would take our price per item, so how much we're selling that cup for, and multiply it by Q. Again, Q is your quantity that we referenced up there with total cost. So revenue is how much money you're bringing in. If we have these cups and we're selling them for $40, you would take the 40 times how many you sell, and that's your revenue. It's the amount of money coming in. Now, probably the one, if you have a business, you're most concerned about is the profit, or you should be. This is the amount of money brought in after expenses. And so this is where it's crucial if you're a business owner to figure out how much profit you have, because the whole point of having your business is to make money. That's when you take your revenue, how much money came in, and subtract all of your cost. And that's also where a lot of companies or startups go awry. They're like, oh my goodness, we're bringing in so much money, but they're not doing their profit equation or situation, and really their costs are too much. And so that's where like pricing your item really well, things like that are going to come in handy. Now, in the middle of all that, whether we're making money or not making money, that middle point is called the break-even point. And this is the level of production is where revenue is equal to cost. And so the amount of money that's coming in is equal to the amount of money that we have spent, or profit is zero. And what we're looking for when we do that is the minimum number of sales for the company to make a profit. And that's important to know that. If you're trying to sell something, you're trying to make a profit from it, knowing when are you going to break even. Now, obviously, we want to be above break even, but having that set value of like, okay, here's the minimum of what we need to be at. The next thing we want to look at is called supply and demand. So we've got this really nice graph to kind of look at as we go through that as well. When we're looking at supply and demand, we're going to hone in and look at if P is the price. And just like what we saw earlier with Q being a quantity, P being a variable for price is also going to be a recurring theme as we go through problems and lectures throughout this course. So if P is the price of a product, then we say capital Q and kind of has a subscript D is the quantity demanded, and Q lowercase little subscript s is the quantity being supplied. And so what we're going to do is, in some situations, we might need to consider both of these as we go through it. And so you can see I've got the quantity demanded equation, and I've got the quantity being supplied. And so when the demand curve, it is a decreasing function. The supply curve is an increasing function. Therefore, the intersection, and I would just kind of jot this down on your notes. The intersection is the equilibrium, price, and quantity. And again, notationally, they might say P with an asterisk, almost like an exponent, and then Q with a little asterisk. And so this point right here is where our demand and supply, the equilibrium of those prices and quantity. And so what I want to do, I really just want to kind of define a whole lot, and then I want to kind of go into some examples and look on how we can use some of this. And so in your notes, I would maybe just hit the high points as writing this down. This is a lot, but I want to show you where I'm getting information from. So I'll kind of highlight what maybe you need to jot down. It says, suppose that the world's current oil reserve is R equal to 2,080 billion barrels. If on average, the total reserves is decreasing by 17 billion barrels of oil each year. Answer the following. So we've got a couple of different steps here. So before we go into A, B, and C, let's just kind of note some important data. Maybe what I would write in my notes, because you should be taking notes as you go through this, is that our oil reserve is 2080. Now, this is also in billions of barrels, so we need to make note of that. They also said that it is decreasing by 17 billion barrels. And so looking at this information, part A says give a linear equation for the total remaining oil reserves. And so I'm looking for total remaining. R is going to be a variable in here, and then T is going to be the number of years since now. And so those are also two important things to note, not only for the online homework, you have to have the right variable, but also noting what those variables represent. And so in this situation, I'm going to say R is equal to, R is representing the billions of barrels that we have, or the total of those. And then it says it's decreasing by 17 billion barrels each year. So that means I'm going to have a negative 17 T. So each year it's going to go down by 17. And we are starting with 2080. So in this situation, it is a linear situation. So that's important to notice, especially as we start grouping ideas together, noting what kind of trend this is. And there really wasn't a whole lot of calculations, just a matter of identifying that information. Now that we have this, and if I was in the online homework, I would submit that and make sure I'm on the right track, that I have the right equation before I do part B and C. B says 13 years from now, the total oil reserves will be blank billions of barrels. And you'll also note that we are in billions of barrels, but we're not using a ton of zeros behind it. Mathematically, we like to be very compact, so we use reference years, or we'll use labels to represent a larger value, such as using the word billions. So if I want to go 13 years from now, that means the total oil reserves would be, well, I'm just going to plug in 13 into my equation. And so we had that R of T was equal to negative 16t plus 2080. And so I'm just plugging in 13 for t. I'm going to use my on-screen calculator. I'm going to enter it just like this, and that's going to give me a value of 1,859. Again, this is billions of barrels. And so part B is not bad. It just wants you to plug into your own equation. Part C says, if no other oil is deposited into the reserves, the world's oil reserves will be completely depleted, all used up, approximately blank years from now. Round your answer to 2 decimal places. And so if I'm looking at my equation, R of T equal to negative 16t plus 2080, I'm not going to play around with numbers and start plugging in years what happened. I'm going for very exact answers. So when I'm looking at when all the oil is gone, so no other oil is being deposited, it's all used up, that means my result is going to be 0 over here. Again, we're taking a mathematical approach. We're not just guessing and checking. And then all I have to do is solve for t. So I'll say minus 2080 gives me negative 2080 equal to negative 17t. Divide by negative 17. Again, just using my calculator, this gives me 1.2235. It did reference and say to round to 2 decimal places. And so I know that that's how I want to round this answer. So this is saying that in 122 years, 0.35, meaning so maybe about March, all the oil would be used up. And that's why they keep on depositing oil reserves in there, etc. So in this situation, just kind of zooming out here and looking at the entire part, we had to create a linear situation, not a ton of calculations in part A, just identifying our values. Part B, we were plugging into the T. Part C, we were plugging into the R. So 2 different situations there. I want to continue this talk and work through some different situations. Here's the next one. And again, with this situation, I want to give you all the information so you can see where these numbers are coming from. It says, when hired a new job selling jewelry, you are given 2 pay options. Option A, base salary of $12,000 a year and a commission of 10%. Option B, base salary of $22,000 a year and a commission of 4%. In order for option A to produce a larger income, you would need to sell at least how many dollars of jewelry each year? So in this situation, this is a commission situation. This happens in other jobs as well, and car selling. And you go, why would I take less commission? Or why would I not take the more salary? Well, depending on option A and B and your life circumstances, you might have a family you're supporting, you're just getting into sales, you're new to the area. So you might go with option B because you're guaranteed you're going to have enough money to help with your bills until you get your sales record up. Or you might be a really great salesman, know the area, everyone knows you. And so you're like, you know what, I can take less in salary because I know I'm going to be able to sell more. And so option A and option B really, in a world sense, is going to base on your life situation. Now, in this problem sense, we want to know, in order for option A to produce a larger income, so what do we have to get our sales to that's going to be a really good option? You would need to sell how much jewelry? So let's look at this. So we're making goals for ourselves because we're going to take more commission, but we want to make sure we're making more than that base salary with its commission in option B. So what we're going to do is we're going to use the information and create 2 equations. In option A, it says you're going to make $12,000 a year and then 10% of your sales. And so if I'm looking at option A, this is a linear situation. In option A, we're going to make $12,000. That's our base salary. Plus 0.10 times our sales, and we'll call that X. Now, remember, when you're working with percentages, you're going to take your 10%, you're going to move the decimal places 2 places to the left, and that's how I came up with this 0.10. The same is going to be true as I look at option B. When I'm looking at option B, we are going to make a little bit more, well, a lot more on our salary, but we're going to be at 0.04 with our sales. Now, we want to produce a larger income. Like, when is it going to be more with these percentages of sales? So I'm just going to set them equal. So I'm going to say 0.10x plus 12,000 equal to 0.04x plus 22,000, and I'm going to solve that out. So first I'm going to get all my x's together. So I'm going to subtract over that 0.04, and that leaves me with 0.06x. Now I'm going to isolate that x, and so I'll subtract 12,000. Gives me 0.06x equal to 10,000. Just using your on-screen calculator to assist you with this arithmetic. And then I'm going to divide both sides by 0.06. So this gives me 166 and 67 cents. Now with this one, it did not tell me round to 2 decimal places or anything like that, but because we're working with money, I know that's an assumed 2 decimal places. So in order for option A to produce a larger income, we would need to sell at least this amount of money in jewelry each year. This must be a high-end jewelry place to be selling all of this. And so you're going to face some of these situations throughout your problems, but the main takeaway is identifying your slope and your intercept, setting up those equations, in this case, setting them equal. So that means once I went beyond this dollar amount, I would be making more on option A that had a larger percentages of sales. And so really, you know what, if I was getting into jewelry business, I might go with option B at first because I may not know if I can sell that much, just depending on where I'm at, the company, and what I'm selling. Let's continue on with some examples here. The next one says, if you decide to begin selling bags of goldfish, well, really changed pace since our jewelry days, selling bags of goldfish at the local swap mart, your cost for each bag of goldfish is $1.51, plus you have to pay a fixed weekly fee of $120 for the booth. Your plan is to sell each bag of goldfish for $2.99. And so let's just kind of identify some information throughout this. First of all, $1.51 is our cost. Each bag is $1.51. Then we also have a value of $120. Just having that spot at the swap mart, we are going to have to pay $120 a week. It doesn't matter how many we sell, they still want us to pay that $120 to occupy that booth. Lastly, it's going to be $2.99 every time we sell one. And so we're just going to kind of work through and create some of these equations as we go. Part A says to write a function to represent your total cost for the week if you sell in bags. And so they are setting up your variables. This is going to be our Y value, and this is going to be our X value. And so in order to figure out the cost of this, because it says write a function to represent your total cost, remember back to what we identified in the vocabulary. Our total cost is our fixed cost plus our variable cost. We have a fixed cost of $120. So I'm going to say $120. Plus we have a variable cost of, it is a $1.51 for us to have a bag of goldfish. And we're going to multiply it by N, however many bags we sell. So let's identify that. So see, N is going to be the number of bags of fish. And then C, again, is your cost. So we have our fixed cost of the $120 for the booth, and then our variable cost of the $1.51 multiplied times our N. So for our cost function, this would be the equation. Part B says to write a function R of N, so they're identifying that for us, to represent the revenue from the sale of N bags of goldfish during the week. Remember, when you're looking at revenue, going back to our definitions, so R is representative of revenue. Sometimes they'll just use R, and you'll have to know that that's revenue. And remember, back with our equations, our revenue is going to be our price times quantity. And that is a known formula that you're going to have to memorize, and it will not be given. So your revenue function is going to be your price, which we're selling them at $2.99 times N, however many we sell. Remember, revenue is how much money you're bringing in. Lastly, we're going to go into C. It says write a function P of N that represents the profits of selling N bags of goldfish in a given week. So profit, we're going to represent by P. That's very common. But remember, with our vocabulary, we said that profit is equal to revenue minus cost. So we've already kind of done our legwork for this one. So I'm going to take my revenue equation from part B, and subtract out my cost equation from part A. So my revenue equation was 299N minus parentheses my cost equation, which is 1.51N plus 120. Now I'm emphasizing the parentheses because I'm subtracting this whole thing. So if I were to come in here and finish this up, because I always want to simplify down to lowest terms, I'm actually going to take this negative and distribute it throughout. So that gives me 2.99N minus 1.51N minus 120. Combining like terms, 299 and 151, that gives me 1.48N minus 120. So this is my profit equation. Last step, so we're just creating equations. We're going to be creating equations a lot this semester, is how many items must you sell to break even? Remember, your break-even point from our definitions is going to be where your revenue is equal to your cost. This is our break-even. So I'm going to take my revenue function, which is 2.99N, and second will be equal to my cost function, which is 1.51N plus 120. And then we're just going to solve for N. So I'll do minus 1.5N. And that gives me 1.48N equal to 120. And then just divide both sides by 1.48. And so that means when N is equal to, we'll take 120 divided by 1.48. And that gives me a value of 81.081. So that means at that 81st bag of goldfish, we're at break even. So really we'll start making money with the 82nd bag of goldfish. And so this was a really good example to help you to see how all those vocabulary words come into play and just some different examples as you work through the homework. Please reach out to your instructor if you need any assistance in that process.